and I will spend some time walking through a simple demonstration, letting you get familiar with it. Let's start with logging into AWS console. We have already prepared temporary free accounts for this tutorial. I think we should already share the landing page and the event hash with you before this tutorial. Now you can open your browser, go to this event engine dashboard, and copy the event hash into this box. And then you are able to log into your AWS account by Amazon account or other social accounts. I will use my Amazon account here. And now you just click on AWS console and click on Open AWS console. Then we are in the AWS console, and we are able to access Amazon SageMaker from here. You can just type SageMaker in the search box, or just scroll down to the machine learning and click on the Amazon SageMaker. Now, as you can see, we are in the SageMaker dashboard. That gives us some basic information about Amazon SageMaker. In today's tutorial, we will implement our algorithms on a notebook instance. We can create it before, because it takes up about 10 minutes to create an instance. And then we come back to the SageMaker dashboard, and I will go into each part into more detail. Let's create one notebook instance by clicking on here. The notebook instance is running a Jupyter Notebook server on it, and we can easily create a notebook instance by clicking on this button. You can define a name for a notebook instance. I will name it as WACV AWS tutorial. One thing I want to mention here, the name of the notebook instance should not contain white space or underscore. I'm using dash here. We can select from a number of different instance types. We have standard instance types for basic computational jobs. We have compute optimized instance types with more powerful CPU, and the GPU instance types that can be used to train and deploy a deep learning model. And we also need to select or create an IAM role to make sure we have proper permission to access data from S3 and SageMaker functionality. Then we can skip the optional sections and click on Create Notebook Instance. Well, as I said, it will take a few minutes to create your notebook instance. At this time, let's back to the SageMaker dashboard, and I will talk about more details. As we can see, there are 5 components on Amazon SageMaker. So SageMaker Ground Truth is a data labeling service, which helps customers to label their data accurately and efficiently. In SageMaker Ground Truth, we have customer or built-in data labeling workflows that support a variety of use cases such as video, image, and text. Then we will talk about the SageMaker notebook experience. The notebooks contains everything you need to build your machine learning workflow. They are preloaded with all common CUDA and CUDA drivers, Anaconda packages, and framework libraries. You can select different types of notebook instances based on the framework you are using in your model. The next component of Amazon SageMaker is our training environment. Amazon SageMaker provides a very easy way for zero setup distributed manager training, which means when you create a training job in SageMaker, we actually spin up a separate hardware for you, provisioning notebook instance, loading a container which have machine learning algorithms, of feeding your data, training the algorithms, outputting the results, and tearing down the cluster when it completes. Another functionality in SageMaker training is the automatic model tuning. Amazon SageMaker can automatically tune your model by adjusting thousands of different combinations of algorithm hyperparameters to arrive at the most accurate predictions the model is capable of producing. It allows you to avoid the tedious trial and error process of manually tuning the hyperparameters. And all you need is just specifying the number of training jobs and configuring the hyperparameters need to be tuned through a console or API, and then the rest of things can be handled by SageMaker automatically. And the inference is how we make predictions with the model we trained. You can create a model from training jobs, or you can deploy it into a real-time hosted endpoint, and you can do a variety of different things with them. For example, your application on AWS simply needs to include an API call to this endpoint or this model to achieve a low latency high-throughput inference on the real-time data or the batch data created by the batch transform jobs. The last component is the processing module. It can help you to do a data pre-processing, post-processing, feature engineering, data validation, model evaluation, and model interpretation on Amazon SageMaker. Those are the key components on Amazon SageMaker. They are tightly coupled on this platform service, but they are also independent, which means you can use each of them independently based on your own needs, and you can access them through the left panel. Let's back to the notebook instance. I think it should be done. Once we click on Open, we will jump to the Jupyter Notebook homepage. You can see there are files where our notebook or our code will be saved in. You can also create a new notebook by clicking on New. And there are different types of notebook with pre-installed frameworks. For example, we create a Torch notebook, which means we can directly import PyTorch without installing it. We also pre-installed very common data science packages on SageMaker notebook instance. We can also import pandas, sklearn, Seaborn, and so on. In the running, we can see which notebook or terminal is running. In the SageMaker examples, there are predefined notebooks we load to the instance before, and those are the good examples to show you how to get started with using Amazon SageMaker. We have examples to introduce SageMaker built-in algorithms such as XGBoost, linear regression, logistic regression, PCA, K-means. We also have some examples to show how to use other frameworks to build customized model. Another examples cover hyperparameter tuning, model monitoring, and so on. And finally, click on Conda. We can see the environment that SageMaker creates for you. As I said, we have already installed very common data science packages on SageMaker instance. You can install more packages based on your own needs. Let's open up a real notebook to see how we build, train, and inference on the Amazon SageMaker. We can just use an example on the SageMaker example. Let's select this example and click on Use. Then this example will be copied to the file. Let's go to Files, and we can open this folder. In this example, I will make a prediction of whether a customer would like to engage with a specific offer by using the SageMaker XGBoost model. This is a binary classification problem making the prediction by analyzing customers' basic information such as age, job, marital, education, and other action history. And XGBoost is a popular, efficient open-source implementation of gradient boosting tree algorithm. The SageMaker XGBoost can be implemented with a smaller memory footprint, and it has better logging, improved hyperparameter validation, and expanded set of metrics compared with the original version. Let's walk through the notebooks sequentially and run the cells one by one. In the first step, we should import the packages we need and configure the path that the data and the model will be saved in. And then, we will download the raw data from the UCI machine learning repository. Once we download the data, we can load the data into the notebook instance by using pandas. Those are what the raw data looks like, and we have the number of features from demographics like age, job, marital, education. We also have features from the past customer events like credit, housing, loan, and other features from marketing contacts, campaign information, and external environment factors. And the final column is our label indicating that whether the client subscribed to a term deposit or not. Now, we need to do some data pre-processing and feature engineering, such as handling the missing values, converting the categorical data to numerical data, and do some feature engineering to select some correlated features to the label. And then, we will split the data into train, validation, and test to do the training, validation, and testing respectively. Finally, we need to upload the processed data into S3 because the SageMaker will load the data from S3 directly. In the next section, we will set up a training job and a hyperparameter training job. In Amazon Automatic Model Training, we will try different combinations of hyperparameters and train the model with those hyperparameters in parallel. And finally, we will find the best parameters of the model automatically. Now, let's set it up. We can create a SageMaker estimator and we can specify some configurations. The algorithm container location is where we will load our algorithms into SageMaker. We can use a built-in algorithm. We can also use customized models. Here, we are using the SageMaker XGBoost image. We also need to define the IAM role to make sure we have permission to access the data and the SageMaker functionality. We'll define the instance types we will use to train our model. I have to clarify here. Now, this notebook is running on a T2 notebook instance, but our training jobs will be implemented in other instances based on the configuration in this API call. In this example, I will train my model on M4 instance, which can accelerate our training progress. We also define the output paths in S3 to specify the model path. And then we need to set up the hyperparameters in our model. For more hyperparameters, we can read the documentation of SageMaker built-in algorithms. And then let's scroll down. We can define the hyperparameters we want to train in SageMaker. We define a Python dict to indicate the hyperparameters and their corresponding range. In XGBoost, the max depth and mean child width are about the complexity of the tree model. And the ETA is a kind of learning rate to XGBoost. And we can also define the type of those hyperparameters. The max depth should be an integer, but others can be the continuous value. Then we will feed this range to hyperparameter trainer. Except that, we also define the model, which is the XGBoost model we defined before, and we will define the objective metrics to compare the model performance with different hyperparameters. We also configure the number of training jobs and how many training jobs can be run in parallel. And finally, we will pass the data to the trainer and start our jobs. This progress will take from a few minutes to a few hours. That depends on how complex your model is and how many parameters you want to train. I have completed this training job before. We can go back to the SageMaker homepage to check the results. And we can say this is the best job, and these are the best parameters. Once we complete the training, we can deploy our model to an endpoint by copying the best model name to the deploy section. And then we can run the model deploy function to create a real-time hosted endpoint. The model deployment also takes about 10 minutes. I have already had an endpoint deployed before. We can go back to the home page to check the endpoint name and use that endpoint to make a prediction here. And this is the endpoint I have. We can copy this endpoint name to our notebook and create a predictor to make a real-time prediction. And this is an example I copied from the test set. And we can say those are the features, and we can feed these features to the predictor, and we can immediately get the results. So this is our prediction. So that's all I had today about SageMaker introduction.